Hello everyone, my name is Griffin Kindred, and in this video I will be introducing Latin square design as well as providing, some examples that I or other engineers would use in their everyday life. So real quick, before I get to the example, I just want to know what is Latin square. So I would just like to explain the basic definition and, what it is. So, a Latin square is an ancient puzzle where you try to figure out how many ways Latin letters can be arranged in a set of number of rows and columns, or matrix. Each symbol appears only once in each row and column. So as you can see here, A only appears once on this row and this column. And as you can see, it's for every letter. And as basic as this may seem, this actually has tremendous engineering benefits. And a quick history lesson, the Latin square was actually called that because it was based on Leonard Euler's work, which used Latin symbols. However, you can use any symbols or numbers you want, depending on, the problem. So, in engineering, as we can see, for structural analysis, such as, building bridges and complex machinery, you're actually going to need to use Latin squares to find out, how to get the most uh, strength out of your tools and the angles that you're going to have to use for, certain vectors. So you can use it for structural analysis, or you can also use it for here at the bottom for like a spring constant to find second order linear equations, which I'm also doing at the moment. So let's get to an example. Okay, so we want to find the cross product for vectors A and B. So A has coordinates 2, 6, 2, and B has coordinates 3, 4, 2. The IJK just means Cartesian form. So here we have the coordinates A and B, and we want to find the cross product. So the cross product is going to give us a vector that gives us a 90-degree at B and also at A with respect to this cross product here. So to find that, you actually need to use a Latin square. So how you do that is, to make it quick, so you have x, y, z, I, j, k, and you're going to need to use Latin square to find 6 times 2 minus 2 times 4. You cross off j, you do 2 times 2 minus 2 times 3, cross off k, and you do 2 times 4 minus 6 times 3. You do all of this, and your coordinate for your new vector is 4, negative 2, 10. And as always, that is the safest thing you can do. And thank you for watching.